This feature is brought to you by students like Austin Jackson who are trying to get their grades up in physics.
We have Austin Jackson here, the physics expert of the universe. Austin, what is Newton's first law?
An object in motion tends to stay in motion, and an object at rest tends to stay at rest.
Look at him go.
Newton's first law. An object in motion tends to stay in motion unless acted upon by an outside.
Me and Austin are about to demonstrate how an object in motion is going to tend to stay in motion. Let's demonstrate, Austin. Any minute now. Now notice how Austin is coming at me at a decent amount of force. I'm about to put an outside force on him. Tennis ball, but notice how he keeps moving. Newton's first law states that an object in motion tends to stay in motion unless acted on by an outside force. And why is it when I threw the tennis ball at your bike continued to move?
Because the tennis ball did not have enough force to stop my bike.
That's right.
And the net force was going forward.
Correct.
I'm about to state Newton's first law. An object at rest tends to stay at rest.
Why did the basketball goal not move, Austin?
Because it has a lot of inertia, which means it wants to stay put.
I'm going to throw a basketball and a golf ball at you. Which one's going to have more inertia?
The basketball.
Okay. Let's see. That didn't hurt that much, did it?
No, it didn't.
Didn't really move much. It was easy to catch, right?
Right.
Okay. Here's the basketball.
Yeah.
Had lots of force behind it, didn't it?
A lot of force.
And why is that, Austin?
Because the law of inertia.
Yep, you're right.
How's the difficulty of stopping the basketball compared to stopping the golf ball?
It was a lot harder to stop the basketball because the basketball had way more mass than the golf ball.
Okay then, Austin, what is Newton's second law?
Force equals mass times acceleration, or F equals m times that.
Correct. Newton's second law incorporates force, mass, and acceleration. Austin, is mass directly or inversely proportional to acceleration?
It's inversely proportional, Trent.
So then, Austin, if I'm going to hit a golf ball and this baseball, the baseball having more mass with the same amount of force, which one's going to have more acceleration?
The golf ball.
True.
Oh, yeah.
Let's see. This is the golf ball. It went pretty fast, didn't it, Austin?
Yes, it did.
Here's the baseball. That went really slow, didn't it?
Pretty slow.
Okay, well that's Newton's second law.
Austin, why did the baseball not accelerate as much as the golf ball?
Because it had more mass, and mass is inversely proportional towards acceleration.
Alright, Austin, you're 2 for 2. Let's see if you can go 3 for 3. What's Newton's third law?
For every action, there's an equal and opposite reaction.
That is absolutely correct. Good job. Austin here is about to demonstrate Newton's third law. For every action, there's an equal and opposite reaction. Say Austin hits the basketball goal with the stick at 400 newtons. How many newtons is the basketball goal going to have to act on the stick?
400 newtons worth.
That is right. So Austin, please demonstrate for these people what it looks like. Now notice how Austin's stick deaccelerated faster than the basketball goal. Actually, the basketball goal didn't move at all. And why is that, Austin?
My stick has less mass.
Correct, and that's Newton's third law. There you go.
Was the reaction force of the basketball goal hitting your stick pretty painful?
Yeah, it pretty much was, and now I really know how it feels, and I know like the whole idea of this chapter in conceptual physics. Trent here is about to do another demonstration of Newton's third law. For every action, there's an equal and opposite reaction.
That's right, Austin. I'm about to hit this golf ball. Now, say I hit this golf ball with 500 newtons of force. The golf ball is also going to hit the club with 500 newtons of force. It's not going to do as much change of motion on the golf club because it has more mass. Let's see. Yep, golf club didn't move much, golf ball did. That's Newton's third law.
Mm-hmm.